talk about trees. Trees are height. What are trees? They are
Tall.
plants. Okay, then
Tall
So-
plant.
Then-
With these stems.
then
Leaf for man. Hey.
Is it clear now?
example.
Mango tree.
Hello?
Mango tree.
Is it clear now?
Guava tree.
Is it clear?
Okay, climbers.
Okay.
Triangle and V.
Okay. So now you can mute your microphone. If you got anything you want to ask me, you can message me on the chat window. It'll pop up on my screen. Okay. So good morning. I'm going to start the demo session on the embedded systems and Internet of Things. So before we go ahead, I'm going to give you a quick introduction about what VLSI Guru is. VLSI Guru is a training institute offering training programs on embedded systems software and Internet of Things. And it also offers courses on VLSI design. So VLSI stands for Very Large Scale Integration. This is nothing but a large number of components are packed, transistors are packed into a small space to build silicon chips. So this is purely meant for students who want to pursue a career in chip design. So they cover with Verilog, physical design, unified Verilog modeling, all those kind of things is what is being covered as a part of the VLSI program. Coming to embedded systems, embedded systems deals mostly with computers which go inside a device. For example, if you look at your laptop is a standalone unit. Your desktop is another standalone unit. Servers is another standalone unit. Web servers and all what you see standalone unit. But there are computers apart from these three categories. Computers which goes into medical devices, aircrafts, cars, rocket, your washing machine, scanners, name it, wherever you see, there are computers going. But there is a difference with the computers like laptops and those computers what go inside the devices. The computer which goes inside a medical device or an aircraft or a microwave oven is called an embedded computer. Whereas the computers what you see, laptop, servers, desktop, they are not embedded. They are outside the world. So when computers itself becomes a component of some other larger system, we call it embedded computer. So this course basically focus on the design of a design of software for embedded systems. Now, what happened is 10 years back, when you say what an embedded system is, there was some definitions. Embedded systems, they were small, really super fast systems. They are very small and all. But today, the definition of embedded system has significantly changed. This is nothing but the introduction of internet. So today we can't think of a computer which is standalone. Even a laptop, you cannot think of a standalone laptop. There is nothing much you can do. You need a simple internet connection. The same thing applies to the embedded computers also. So if you are learning to design an embedded computer, you need to know computer networking, you need to know a little bit of computer networking and how computers are connected to the internet and do various network transfers. So when we learn about embedded systems, you need to learn about Internet of Things also. So the concept of embedded computers are finding large amount of application in the space of IoT or Internet of Things. So that is where things are going towards. So the focus of this course would be on the development of software for embedded computers and how do we integrate that software with the latest technology, which is the IoT. So what exactly is the course. So the course offers roughly, this is a rough figure, offers about 16 weeks or around 100, maybe 100 hours of lectures and video covering important aspects of software design and IoT. So there will be lectures, technical discussions, assignments, hands-on exercise, projects, and few mock interviews and mock tests if you wish to take. So there are different types of students coming to us. Some of them want some interview practice and model tests on the questions they will be asked. So we will give them. Whereas those who are already employed, who are coming here for knowledge, they focus on lectures, technical discussions, and projects. It's purely from the learning perspective. So depending upon the student's interest, we will have this mock interviews or model tests. So this is basically when students ask for it, we do these things. Otherwise, this is the most important aspect of the program. Okay. So mock interviews, what we normally do is, if you are able to come to institute, we will do it at the institute. If you fix up a time, otherwise we will do the telephonic interviews. So typically these days in United States and in India, lot of interviews happens over the phone. So how do you present yourself through the phone? That is where I normally explain what kind of questions you can get. Those kind of things will be. And model test is again what kind of questions you can get for the interviews. It's get you up to the track before you face an interview. So that is the high level view of how the course is done. So lectures, I will walk you through the concepts, and those questions we will take it for discussions. In addition, I will bring up some topic and ask you some questions, and we'll discuss on that. And we will discuss few hands-on exercises and few case studies. And I will give you some kind of homework for you to try. That's called the weekly assignments. You need to do it and get the expected results. Some of them I will go through it. And towards the end, or once we are 3/4 of the course, I will ask you to take up a small problem as a project and do the whole thing where you need to do a lot of research. So in assignments also you need to do research and find answers. It's not everything given to you on a plate. I will give you problems. You need to read through the problems, listen to the lectures, listen through the case studies and the video discussion on the videos, and do research and do the assignments. So that is how you are expected to do the weekly assignments and projects. So the difference between weekly assignments will be short, relatively small problem. Project will be a little of a larger scale. You need to write a lot of code, integration, and things like that. So what's going to be the agenda of this presentation? We'll already explain the objective of the course, who should attend. I gave you a quick overview about the embedded systems and IoT, the future of embedded systems. All those things we will cover. Okay. So let's first go through the objectives of this course. So the objective of this course is basically for you to understand the components of what an embedded system is, develop sound knowledge and skills to build an embedded software, and also learn to understand about sensors and actuators. Also, you need to do all these things. You need to develop a sound knowledge of C programming, and you should develop good programming skills also, because most of the software today we develop is written around C, and some of them are written in Python. So without C programming, if you touch this embedded systems, it will be really difficult. You won't get the foundation. Once you get the foundation, it does not matter what programming language you do. You can apply that to any programming language. That does not matter. So who are the target audience? Students who are doing master's level course and interested in learning about embedded systems and IoT, fresh graduates with engineering background who would like to augment their knowledge on the IoT and embedded systems, those who are employed in some companies, and faculty and staff. So any of these people can take this course, and they will find this course really useful. So let's go to what an embedded system is. I already explained to you what an embedded system. When a computer itself becomes a part of a complex system, we call that as an embedded computer. So laptops and servers are not a computer. whereas the computers, what you find in all these things are basically embedded, starting from the drones, watches, cameras, cars, aeroplanes, microwave. All these comes under the category of embedded systems. And what about Internet of Things? So Internet of Things is really needed when that embedded computer needs to communicate with some external entity. So a very good use case is, let's say you have a car and you have a mechanic here. So you bought the car from the dealer, the mechanic inspected the car, and you have been you've been handed over the car to you. Now you're driving around all around the place. Suddenly the car develops a fault. What do? You call the mechanic. The mechanic sends a tow truck, pull the car to the workshop, open it up and fix it. But what happens when the car breaks down? If it sends a message directly to the mechanic where you are stuck, and the mechanic immediately deploys a tow truck, that will be really amazing. Before you call up, the mechanic will get to know you have a trouble, and he sends. This can be actually done with the help of IoT. So what the car does is, the embedded computer in the car does is, pick up signals from the GPS, send it to the internet, and through the internet it reaches the mechanic and it beeps, and the mechanic deploys an emergency tow truck or a person, to field person, to come and help your car. So that's the first use case. Second use case is, your car is equipped with an array of sensors. Let's say heat sensor, vibration sensor, you name it, different types of sensors, speed sensor, etc. And also it measures the amount of emission it is doing. Like that, there will be 10 or 15 sensors. And this data is constantly transmitted to your mechanic's computer somewhere far away. And computer and mechanic's computer do perform analytics on that data and get to know the health of the car. Let's say you are going out for a drive with your family, and suddenly the car breaks down. You go through the same painful process, right? But when the analytics data is made available to the mechanic, the computer at the mechanic shop will be able to predict a potential failure of the car and alert you. Hello, we'll call you. Sir, your car seems to have a trouble, so don't take your car. Instead, you take a taxi or a cab and travel, because I see a problem with your engine. I'm sending a mechanic right now. Which is far better, because the mechanic is able to proactively understand if a potential failure with your car and sending a mechanic to your home. So instead of taking the car for a picnic and half the way getting into trouble, you take a rental car or a cab, and then you go for the picnic, and your mechanic will come take the car to his place and get it repaired. So these are the things which are the use cases which is happening today with IoT. So the embedded computer in the car is what is doing all this magic. So there is another use case. Now imagine the car you are driving encounters an accident. What happens? Either you will be injured, you need a lot of things. The moment when the car hits with an accident, the special sensors which are mounted on the car detects this, and the embedded computer in the car get to know about there is some catastrophe, gets the location, and immediately transmit the information into 3 different spots. First, it will be sent to the ambulance. Second, it will be sent to the mechanic shop to the help, and the third one to the police. So as soon as this comes, the ambulance service will deploy an ambulance, your mechanic person will send a mechanic, and the police will also come in the stop. It does not matter what your condition is. In case if the driver is unconscious, still the ambulance will come to the spot, the police will come there, and as well as the mechanic will come to remove the car from the stop. So all these things happen completely without the human intervention once you have a IoT enabled embedded computer in your car. So this applies for any kind of automobile, let it be a car or a truck or a jeep or a motorbike or a cycle, everywhere you can have this use case. So this is how in future the embedded systems are going to get deployed, and this is exactly the reason why we decided to cover IoT also as a part of the embedded system. Embedded computers do not exist in standalone; they exist as an IoT device going forward. So, what exactly, apart from this, what is the relationship between IoT and embedded? So, computers are evolving, embedded systems are also evolving, and the internet has made a big time impact. Not just with the case of a automobile, this concept of internet enabled embedded computers are finding applications for your home automation, your automobiles and aeronautics and airline industry, hospital and healthcare, space and defense unit, manufacturing units, and including banks and insurance companies. For example, so students ask me, how do banks and insurance companies find this useful? Because they are more of a financial institutions. Yes, they find use with this. Imagine the car what you're driving here is enabled with all these sensors and gadgets. You don't come across with any accident. Still, your data, the performance of your car as well as how you drive the car on the road is transmitted to the insurance company. Insurance company, based on that data, will get to know how safe you are as a driver. Accordingly, your premium will be calculated. Similarly, the insurance company or somebody can get to know the health of your car and see whether are there any potential problems coming, whether it's time for a service, are you doing the service of the car right on time, etc. They will check. So banks and insurance companies do find use with the data on how you are driving a car. Manufacturing units. Today, a lot of optimization, because in any manufacturing segment, optimization is the key. The performance optimization needs a lot of data about how the machines are functioning, how much energy each and every equipment is consuming, and what is the productivity. All those things is constantly monitored. Today, we need the data to do analytics and do the optimization. So there too, significant amount of IoT and embedded systems comes into the picture. Hospital and healthcare, by now, I think you will be able to guess where IoT and embedded systems comes into the picture in the hospital and healthcare. So what is the future of embedded systems and IoT? So it is expected by 2020, the market size for the IoT would be around $3 trillion. So this is based on a survey by one of the management consulting company called Gartner. So they believe by 2020 the world will be spending about $3 trillion. So that means every device what we use today will be internet enabled. The moment when you say it's internet enabled, there is an embedded computer coming inside it. So that is how the future is. So I'm not going to articulate this part with reference to how many number of jobs available in each country. That is something which is impossible for me to do. But in general, as per the predictions given by Gartner, this is where it stands. So that is just an overview. Now, coming to the more technical details, what are the three main components of an embedded computer? So the three main components, just like any other computer, here also, it's the hardware, you have the software, and the internet connectivity. So in short, the embedded computer do not differentiate too much or differ too much from the traditional computers, what you have come across. They also have the three main components. Here also the three. Only thing, the way these are deployed is slightly different. So that is where the real difference between an embedded and a standalone computer comes in. So how do we do the development? Yes, when it comes to development, it slightly changes. That's where I was saying the way it is implemented or the way it is being deployed. So if you're doing a development on a laptop, software development on a laptop, you buy the laptop, you buy a compiler or something like that, you develop the software and deploy it. It's straightforward. But here, it is slightly different. This is because each company uses different embedded computers based on their requirements. there are a host of companies which are making boards, printed circuit boards for embedded computers. So they are called hardware suppliers or embedded hardware suppliers. Few of the embedded hardware supplies are ST Microelectronics, Broadcom, Raspberry Pi Foundation. Then there is another open source foundation called Arduino. Like that, there are so many companies who supply the embedded systems hardware. So you buy the embedded systems hardware from that company and get the understand the specifications of that particular board. So each board will be different of its own. Just because you have learned on one board does not mean the same principles will apply. High level they will be same, but at the implementation level there will be a lot of difference. For example, ST Microelectronics board is significantly different from Raspberry Pi. ST Microelectronics significantly different from Broadcom. So like that it differs. So that's the way it goes. Now then the software engineers will develop the software with the systems knowledge, and they will also develop the software, the needed software to interface with the network so that it can talk to the internet, and finally it is deployed. The whole software is deployed on the hardware and it is tested and fixed into one of the device. So that's how a software is developed. The life cycle is more or less the same, but only thing the way it is deployed is different. Now let's go little more into the next level, double click onto this particular board, what is there inside the board, and see what is the next level. So that will give you a little more understanding about the development process behind an embedded system. So if you look at your college days, you would have seen one diagram of a computer. Computer has got inputs, computer has got outputs, it has got a CPU, memory, that's it, and maybe a network interface. So the architecture of an embedded computer is also not much different from that. But there is a slight difference. It has say exactly like a traditional computer, it has got CPU and main memory. But when it comes to the secondary memory, there is a difference. Very few embedded computers today use the concept of hard disk. Instead, you have something called a memory card. You would have seen this memory card on your mobile phone, your camera and all. So that kind of memory card is fixed onto an embedded computer instead of a hard disk. That's the first difference comes. Second difference is, on your laptop or any other thing, the input is usually from a keyboard or a mouse. Whereas on an embedded computer, a keyboard or a mouse may be there, may not be there. It's an optional thing. In addition to keyboard and mouse, there will be host of other inputs, devices called the sensors. So the sensors collect data and input to the system. So in an embedded computer, you may find a keyboard or may not find a keyboard. If it is there, it may be a touch keyboard, something like that. And for sure, there will be a host of sensors connected to that. In a traditional computer, you have a display, an LCD display or one of those displays or a TV screen. But on an embedded, it will be completely different. Usually, the display on an embedded computer is a touch screen LED. It acts as a both input and output. Instead of a keyboard, it will have a touch screen which will act as a both input and output. An electric motor might be connected to that. You might see an electromagnetic relay. You might see an LED or a LCD or a LED screen or a LED 7-segment display. A host of output devices will be there. Traditionally, on a laptop, you will find only two types of output. One is a screen, your LCD screen, and as well as a printer. But here, printer and those kind of are optional. But you see electromagnetic relays, electric motors. These electromagnetic relays, electric motors, etc. are called actuators. So you have on the input side you have sensors, and on the output side you have actuators. So display is just one among the output device, but display is not called as an actuator. The electromagnetic relays, motors, etc. are called as actuators. In addition to this, there is something called ports. So if you observe your laptop, there are one or two types of port. One port what you commonly see is your USB port. The other one is your display port. Whereas on an embedded system, there will be lot number of ports. Ports are the terminals onto which you connect your input output device, and these ports will be addressable. So if you want to really learn how to write an embedded system software, the first and the most important thing you need to learn is how to access these ports. What are the different methods of accessing this port? How can you read data from this port? How do sensors talk to these ports? So these are the things. If you understand that and get the data from the ports to a variable in your programming, then your 50% of your work is done. The next 50% lies in how do you communicate with your actuators. What are the protocols these actuators you need to understand. So the moment you understand how do you take an input from the port and how do you give the output to the actuators, your 80% of your course is done. The next 20% lies in learning the programming side of this. How do you make use of the programming side? So that is the key part about that. Then comes the network interface. So in a nutshell, if I say that, the challenge with the programming learning thing comes in a significant amount, maybe 40 to 50% comes in learning how the input devices are configured or how do you collect input. Another significant portion comes on how do you communicate the output, and the middle, the last 20, the most critical 20%, 30 to 20% comes in how do you write the software for this. Then comes how do we integrate that software with the network. But network interface these days are pretty well matured because a lot of APIs are available. You just need to learn how to use those APIs. So the moment you get all the three factors in one place, you will be able to develop software without much of problem. Now comes what are the tools required for the software development. So in a typical laptop or server based software development, you need basically a compiler, you need a debugger, that's it. Either you need a compiler, interpreter or a debugger, then you can run it. But in embedded software, that is not the case. You still need compilers or interpreters, you need debuggers, and that too little more complicated debuggers maybe in some cases. You will need assemblers, and you need something called a simulator. So what is a simulator? The simulators are basically simulates the real world devices. Coming back to our previous diagram, you see a host of sensors. When you do the software development, you may not be able to you may not be able to get all the sensors on time. So how do you test your software without this real sensors or these actuators ready with you? There you implement something called a stub or a simulator to simulate these sensors and simulate these actuators and see the software is really working or not. The development of simulators is something little advanced, but towards the end of the course you will learn. I will give you idea about how to write the simulators. Then you have the test bench, because you simulate sensors using the sensors using simulator, send data, and you need somebody, and it goes test bench, and you need to goes to actuator simulators, and then you need a test bench to see whether this is working fine or not. So that is how the software is developed. So just a small break. Are there any questions from your side? Any questions? San, Sanji, Sanjita, is it clear to you? Any questions from your side? No, say the question is, Sai Kiran has got a question. His question is, are we going to, which is the operating system we are going to use? It will be mostly focused on Linux. Linux is where I will be using. I will be teaching you Linux, and I will be touching upon the concepts of RTOS, and there will be some of the hands-on session on RTOS, which is called the free RTOS. And his second question is, will be touching the kernel. No, I will not be touching the kernel in this course. Kernel is not part of this. So how do we integrate, coming back to our presentation, how do we integrate sensors to the embedded computers? Usually there are certain protocols defined for this, just like USB. In case of desktop, there will be something called I2C, SPI, UART, etc. So I will be covering at least one of these protocols based on the availability of time and your interest. Let me tell you, this I2C, SPI, and are a little advanced. Unless I am confident that you are reached a level to learn the protocol level, only I will cover. If you're really interested and you pick up, definitely I will make sure that I will teach you these concepts also. But that will be based on your interest. So we already explained what the Internet of Things are. So another question which comes about is, to what extent an embedded software engineer should know about computer hardware? So yes,
Hello?
10 years back, just a minute.
Okay.
Hello folks, I'm back. Sorry, there was a small interruption. So to what extent you need to know? You need to know the basics of hardware board, processor, memory map, ports, etc. So you don't need to know circuit level or chip level knowledge. Circuits, that is not needed. But wherever you need some amount of knowledge about circuits, I will be explaining to you. But otherwise you need to know what a processor, memory map and all. And whenever you need, you can always research on the internet and get to know more about that. So I will give you some reading material for wherever you need to go deep on the hardware side, but usually that is not very much needed. But you should know digital concept, the digital logic circuits, AND gate, OR gate, NOT gate, flip-flops, mux, those kind of things definitely you should be knowing. I guess by now you would have learned those things. If you have not learned it, you may have to take you have to watch some of the videos which we have on the internet. So looking at all these facts, the concepts of embedded computer, the architecture, the sensors, actuators, all these things, we have designed the course content for you. So in the next slide, what I'm going to explain to you is what is there in the course. So slightly something like a syllabus kind of thing, you can call it, but not exactly. So that's the way it's going to go. But this will give you a high-level view about what are the things we are going to cover in the course. So we'll start the course with a overview of embedded systems. and I will give you a quick refresher on analog and digital concepts, basically what's the current voltage and all. Then we will get into the architecture of the embedded computer. Then operating system fundamentals. You need to know an operating system. Most of the embedded systems today do have an operating system. Then I will explain to you the concepts behind compilers, assemblers and interpreters, and then show you how to compile a small C program on an embedded box. So we will be taking Raspberry Pi as the typical sample computer or the platform, hardware platform on which I'm going to teach you all these things. And then from there, once you learn how to compile a sample program on the Raspberry Pi, you can start on the C programming fundamentals. I will take you from the printf, scanf kind of things, very bottom of C programming, take you all the way to the data structures. I will be covering linked list, stacks, queues, etc., what is needed for the embedded programming, and take you to the various case studies in C programming. After C programming, I am confident that you have understood C. I will give you an introduction to object-oriented programming using C++. Remember, I won't be teaching you the entire C++. I will be giving you an introduction on C++ about the data hiding, encapsulation, inheritance, and polymorphism. So this is needed because sometimes on some boards you will come across C++ APIs when you talk about the embedded computers. So you should be knowing something about C++ for that. Then I will be introducing you one apart from Linux. So all these things I will be taking you through the Linux part, and then I will be introducing you the real-time operating system, which is nothing but the free RTOS. After which I will give you introduction to Python. So why Python? So Python is something fast evolving on almost every environment. On every environment. So knowledge of Python is really needed. It will be very helpful for you going forward. You can do embedded system development on Python also. So I will be covering you some fundamentals, some foundation on Python, on how do we do software development on Python. Then I will be covering the concepts about sensors and actuators. I will be covering about 2 to 3 sensors and 2 to 3 actuators as samples. The thing is, why I am selecting only 2 to 3 is there is a large number of sensors and actuators in this world. Most of them are evolving and something are going obsolete, new sensors and actuators coming. None of the courses will be able to cover the entire world of sensors and actuators. So for your learning purpose, I have selected few sensors and I will be teaching you based on that. Once you understand that concept behind this, any new sensor or any new actuators coming in the market, you will be able to look at the specifications and then go ahead with it. Then I will from there I will get into the IoT concept, IoT and computer networking. So basically I will show you the socket programming API on Linux, how to talk to another computer on the network. Then I will be showing you how to interface with the sensors and actuators. So that up to topic 1 to 16 we cover most of the important part of the embedded part. By then you will be in a good shape to understand how to build a small embedded system using a sensors and actuators. Then I will be touching on the fundamentals of ARM microcontroller or the ARM processor fundamentals. So ARM is one of the fast evolving processor architectures in the market. So they have come out with A series, R series, M series and all. So M series is the microcontroller part. So I will be helping you to understand the concepts behind the ARM microcontroller. So this is the microcontroller we will be discussing in the course, and we will be doing hands-on with the ARM using the Keel simulator, because the ARM, for every microcontroller we cannot get a hardware board. It will be really difficult. So I will show you how to install a free software on your laptop and do all your programming over there. So that is done with the ARM, with the Keel simulator. And I will give you some comparisons between various processor architectures like A series, R series, M series, Cortex M4, A53, etc. So that is the high level view. So in short, we will be covering the programming using C and Python, the operating system fundamentals and operating system APIs on Linux, one RTOS, real-time operating system called free RTOS. Then how do we integrate your computer program with the network, computer network, sensors and actuators, and one microcontroller from ARM, and an overview about the ARM processor architecture. So this is the high level view of the course today. So what are the job opportunities? As I mentioned earlier, the IoT field is rapidly growing in India. By 2020 itself, they are talking about the number of is expected to grow to about 1.9 billion units. So in India itself, they are expecting a market of 9 billion. So definitely industries in the area of utilities, manufacturing will need IoT. Healthcare, retail, everybody will need IoT. So that means definitely India will need more people who has skills on embedded systems and IoT going forward. So if you want to know more about this data, what I just presented, I took it from this particular link. So this particular link explains this. So based on this only I have talked. So after the course, what are the support? So we will do two types of support after the course. So we do mentoring of the students. Basically, as I told you in the beginning, we'll help you with some mock interviews, mock tests, etc. if you like, some telephonic interviews, etc. If you want. And also we do mentoring. For example, I want to something which is not as a part of the syllabus we did not cover, still you wanted to learn. If you have got any doubts, we will mentor you on that. We will not be teaching you, but we will be giving you some guidance on that part based on your needs. And whenever you want to replay the lectures or you missed a session, you can always come to the institute and listen to that, or on the online students can listen to the backup classes. They will replay it for you through the recordings. So this is the high level overview of the course, and if you got any questions, you can ask me. Either you can ask me through the chat window, or you can ask me verbally.
Hey Girish.
Yes, Sanjita, right?
Yeah, this is Sanjita here.
Yeah.
I saw you're going to teach about RTOS 2 and Linux. And I'm new to this both of environments. How is it going to be? Are you going to start from basics?
Okay, sure. I'll explain. Can I answer? Question? Okay.
Yeah.
Sure. So Sanjita's question is, she heard about Linux and free RTOS in the presentation. So she's saying that she's completely new to all these things. So where do you start from? Okay. So coming to the Linux, before I enter the Linux, I will be starting from the root basics of operating system. What an operating system is, why do we need an operating system? All those things I will be first teaching, and then from the basics of Linux we will start. And I will take you up to the inter-process communication on Linux, IPC. Up to there I will teach you on Linux, which is fairly good enough to do a job in an industry today. Up to there, if you know fairly good, I will be taking you up to there. And free RTOS is another free operating system which is right now owned by Amazon. intended for the embedded systems market. So that also I will be starting from the basics, and I will be showing you how to write some programs on there also. So basically we will be starting from the basics from both of the cases, and Linux is where we will be spending most of the time. Most of the work we will do on Linux.
I thought I wouldn't do all the cue cards in the book.
Is that clear, Sanjita?
Yeah, got it.
All those things go into the room, keep it in the study area. Adi, keep book in the study area, okay? And then all your crayons and sketch pens are there, no?
Sai, Kiran, any questions from you?
Yes, what are timings about this?
Okay, so you are
Like
taking the online session, right?
yes, yes.
Okay,
Yeah.
so basically the way it works is weekly once there will be a lecture. Mostly I plan it on a Sunday evening. It depends because I'm employed somewhere, and I need to manage my time. So I plan it to do on Sunday afternoons, and you can connect to the system just like you are joining now and listen to the lecture, and the same will be recorded also. So in case you could not listen to the lecture at that time, does not matter. You can always call up the institute and say, I missed the lecture. They will make it available for you to listen, and then you can email me the questions you have, the doubts you have, or you can WhatsApp me or talk to me, whatever it is. So for an online student, you look at it like this, about 3 to 4 hours of lecture per week. That's how we go about it.
Okay. Yeah.
So reason why we do like this is there are a lot of students from overseas like US and UK who wants to take this course. So we cannot have a time which is common to all the people from various time zones. So we record the sessions, make it available to them, and so that they can listen to it at their own convenience, because their work hours, study hours are all will be different. So we give that level of flexibility to students.
Okay. Thanks.
Sure. So Sanjita, any more questions from you?
No.
Okay. So if you have got any more questions, feel free to speak to me, or you can WhatsApp me, or you can email me, either one of them, and then we can discuss. Okay. So thank you very much. Can I wind up?
Yeah.
Okay. Okay, sure. Thank you very much. Bye-bye.